Hi, for the continuation of the wastewater treatment and technology, we will move on to the unit operations of pre-treatment. First, bar racks. Typically, the first device encountered by the wastewater entering the plant is a bar rack, the primary purpose of which is to remove large objects that would damage or foul pumps, valves, and other mechanical equipment. Large objects include stones, rocks, debris, and metals. Rugs, lags, and other objects that find their way into the sewer are removed from the wastewater on the racks. In modern wastewater treatment plants, the racks are cleaned mechanically. The solid material is stored in a hopper and removed to a sanitary landfill at regular intervals. Now let's move on to the grit chamber. Inert dense material such as sand, broken glass, silt, and pebbles is called grit. Three basic types of grit removal devices are available. We have the velocity controlled, also known as a horizontal grit chamber, aerated, and the vortex chambers. Only the first, which is the velocity controlled, can be analyzed by means of classical laws of sedimentation for discrete non-flocculating particles, which is the type 1 sedimentation. So if these materials are not removed from wastewater, they abrade pumps and other mechanical devices, causing undue wear. In addition, they have a tendency to settle in corners and bends, reducing flow capacity and ultimately clogging pipes and channels. Liquid velocity control is achieved by placing a specially designed weir at the end of the channel. A minimum of 2 channels must be employed so that one can be out of service without shutting down the treatment plant. Cleaning may be either by mechanical devices or by hand or manually. Let's try to solve a problem related to pre-treatment. Will a grit particle with radius of 0.04 mm and a specific gravity of 2.65 be collected in a horizontal grit chamber that is 13.5 meters in length if the average grit chamber flow is 0.15 cubic meter per second? The width of the chamber is 0.56 meters and the horizontal velocity is 0.25 meter per second. The wastewater temperature is 22 degrees Celsius. Okay, so let's solve this problem. It states in the problem that the wastewater temperature is 22 degrees Celsius and we need to find the density of the particle, which we have given the specific gravity to be collected. So for the density of the particle, it's 2.65, which is the specific gravity, times the reference density, which is the water. The density of water is 1,000 kilograms per cubic meter. So it's equivalent to 2,650 kilograms per cubic meter. Now we already have the density of the particle. The next thing we're going to calculate is the settling velocity of the particle. We will use the Stokes law. So for the formula of Stokes law, it's the settling velocity is equal to the gravity times the diameter of the particle raised to the second power multiplied by the difference of the densities divided by 18 times the viscosity. Now, in the problem, we don't have a viscosity given, but we are given a temperature of 22 degrees Celsius. So I'm going to show you on how to determine the viscosity of a wastewater at 22 degrees Celsius using the thermodynamic properties of water. So this is the thermodynamic properties of water. And if we are going to convert 22 degrees Celsius to Kelvin, it's equivalent to 295.15 Kelvin. So in this part, the upper part here is the saturated liquid, and this lower part here is the saturated vapor. And the table 2-305 is for the superheated liquid and for the superheated vapor. So we're going to determine the viscosity here in the saturated liquid. So just look for the 290 Kelvin and 300 Kelvin. So between these numbers, so we are going to interpolate 295.15 between these two numbers. And if you look into the right side, we have here the viscosity, which is in micropascal seconds. Okay, on your calculator, and then click mode, then choose stat, and then click number 2, which is a plus b x. Then input 290 and 300 for the x value. And for the y value, just input the 1084 for the 290 Kelvin and these 853.84 for the 300 Kelvin. After completing the details for the x and y, click AC, and then click Shift, click 1 for stat, and then click 5 for regression, then click another 5 and input 295.15. So you will get a value of 965.97 micropascal seconds. So our value now for the viscosity, right, this the viscosity. It's equivalent to 965.47 times 10 raised to the negative 6 Pascal seconds. Okay, so for the gravity, we have 9.8 meter per second squared. For the diameter of the particle, it states in the problem a radius of 0.04, so just multiply by 2, it's 0.08. Then convert to meter times 10 raised to negative 3 meters. Then the difference in densities, we have the 2650 kilograms per cubic meter minus the 1000 kilograms per cubic meter divided by 18 times the dynamic viscosity, which is our 965.47 times 10 raised to negative 6 Pascal seconds. Okay, so our settling velocity here is equivalent to 5.95 times 10 raised to negative 3 meters per second. So this is our settling velocity. Now we already calculated the settling velocity. The next thing we are going to calculate is the area, which is equivalent to the volumetric flow divided by the horizontal velocity. So area is equal to the volumetric flow divided by the velocity. For the volumetric flow, we have 0.15 cubic meter per seconds divided by the velocity, which is 0.25 meters per second. So we have an area of 0.60 meter squared. Now, after solving the area, we need to solve for the depth of the flow. So solving for the depth of the flow, we are looking for the height here. So height is equal to the area divided by the width of the chamber. So we have the area of 0.60 meters squared divided by the width of 0.56 meter. So we have a height of 1.07 meters. After solving for the depth of the flow, the next step is to solve for the time if grit particle enters the grit chamber of the liquid. So solving at the liquid surface. So for the time, it's equivalent to the depth of the chamber, which is 1.07 meters, divided by our settling velocity, which is 5.95 times 10 to negative 3 meters per second. So our time here is 179.83 seconds. This is our time if grit particle enters the grit chamber at the liquid surface. Now we need to calculate the time the particle will travel to the horizontal grit chamber. So the time is equal to the length of the chamber, which is 13.5 meters, divided by the horizontal velocity, which is 0.25 meters per second. So our time here is 54 seconds. So therefore, the particle will not be captured in the grit chain, since our time is less than the time if the grit particle enters the grit chamber at the liquid surface. So that's all for the pre-treatment, and for the succeeding lecture, we will have on the next lecture video.